In episode 1, we learned that how registers are the CPU's workspace. In this video, we will learn how to utilize those registers and create a library from which we will be able to call subroutines and animate horizontal lines, vertical lines, and square. So we'll create a library.asm, which we won't be compiling, rather we will be importing it in our main.asm file from where we can call those subroutines by setting our register values and then calling them and just creating the animations. So I've created three files here. One is main.asm, the other is library.asm, and one is for character controller.asm. So first of all, we will be writing a library, basic functions like draw line, vertical line, draw horizontal line, draw square, uh, how to do character animation, like individual characters of text animating one by one in a like teletype output. So all of those sort of animations we can write in this library, and then we can call this library from our main file. So basically what will happen is that we'll say percentage include and library.asm. And what this does is basically just takes all the code from here and pastes it over here so that we're able to use all the functions in library.asm inside main.asm. It's basically just doing that. It's kind of like export or import in Python, but not exactly like it. On the other hand, in library.asm, should we start with or RG100H? Well, no, because remember, this is just a library for function or utilities. Uh, and this will be our main functions. This is something that will be starting with org100h because this is something that we will be compiling, and then the output will be shown to us. And this is just a library, so we don't really need to basically do much for this library. Now I will be zooming in a bit. Just close my terminal so that it's clear to everyone. And then I'll also be toggling word wrap. So if my program goes out, which I don't think it will since it's assembly, it doesn't go out of the documenter, so that I don't have to scroll towards it, right? So the first function that our first subroutine or first label that we're gonna write is the put underscore pixel. Now, what is put underscore pixel? Now, put underscore pixel is basically saying draw underscore pixel. I like to call it put. I don't know why I would like to call it put, but that's just how my brain functions. So basically, this function will help us in placing the pixel onto our screen, right? So what's the first thing that I do in put underscore pixel is push A. Now this is something new that we haven't discussed before, is that push A, what it does, it basically pushes all the general purpose registers. So like AX, BX, CX, DX, all the general purpose registers, and it pushes it up the stack, right? So why it's needed? Because sometimes we want to save the value. Since this is not a simple label that we will be using jump to, instead this is something that we will be calling using the call function. So if I'm in another function like, let's just call it label for now. And in this label, let's say I'm calling put underscore pixel. That means that after it's done executing, the flow will return to my label because that's from where so I have to use a return function and the return variable at the end of put pixel so that it returns from where it was called from. So now this is a subroutine. It's not a simple label, right? Now, the first thing I'm doing is push A. Push A basically pushes all our values inside our general purpose registers onto the stack so that after I'm done playing around with the AX, BX, and DX inside this function, I can just pop A. And that will just give me back the values that I had. So basically, if I'm in some other function, right, and I have move AX, 0x, 001, something else in BX, right? So if I want to be able to save these values, let's say I come here and I change these values AX to, let's say, 10. So now this value is overridden. But since we are pushing A, this pushes the AX up the stack, right? So 0x0001 is saved for me, and also 14 is saved for me in the stack. So when I'm popping these values over here, then it just pops the variables and it just puts them back into back to their original values, all the general purpose registers. So that's why we're using it, since we will be calling it from multiple sources when we are animating things. So I guess there's that. Okay, so the next thing I'll do here is move BP AX. So what this is doing is this is basically saving my AX register, whatever is in my AX register inside BP. Why we're doing that? Because remember, when we are printing anything, any kind of pixel on our screen in assembly, we need to use the AL register, which is the lower part of AX register. We need to use it to save the color of what the pixel would look like, right? So I need to use AX register later on for something else. So that's why I'll be saving this AX register in the form inside BP, so that I don't lose my data that is inside AX. The next thing I'll do is move dx, move bx. Now my dx. Now we know that our y coordinate is saved inside dx, so I'm saving it inside bx because I have to perform some math for it, and because of that, there's a bit of bigger picture to this statement. So as we move on, writing more lines of code, you will understand it more. So the next thing I'll do is, now that I have my DX register free, I can use my DX register to point it towards memory. So 0A00H is basically the address for VGA graphics mode. I know we've been using something else previously where we're using AH and AL, but now we'll be using this because for me this looks a bit more professional. The next thing I'll do is point our extra segment towards dx. So what's I mean dx towards extra segment. So now my extra segment is basically pointing toward saving 0A00H. That means that the extra segment register is basically pointing towards our VGA memory. Now, when we're thinking about this function, we have to think about generalizing it. Now, what do I mean by that? Later onwards, we will be calling this function for, let's say, draw horizontal line. So we'll be calling the put pixel label from this draw horizontal line. That means that it will be used to draw a horizontal line, and then maybe we can increment some value to, cause that animation effect. And let's say later onwards, I call the vertical line function, make a vertical line label, and I use the put pixel function again. Now remember the label or the subroutine remains the same, but I'm calling it from two different functions. That means that it needs to be a generalized solution that works for both. So how can we achieve that? The first thing I'm going to do here is move AX 320. Now remember that in VGA mode, each row has 320 pixels. That means that each row from starting to end, so let's say this is the start of our VGA mode row, and this is the end. So this entire line has 320 pixels. So I don't want to draw in the start of the screen. I want to draw in the middle of the screen. So how can I reach the middle of my screen? So I'm moving AX to 320, and then I'll multiply it by BX. What does multiplying it by BX does? So we know that BX is our Y coordinate, and AX, which is 320, is our one row. That means when I'm multiplying it by BX, which is a Y coordinate, it will go to that position. So if that position is, let's say 100, that will go to the middle of my screen, right? If BX is basically equal to 100, let's say, just for an example, I know this is not how it works, but let's say BX is 100. That means that we'll be going to the middle of the screen, because 320 by 100 will be 32 something, big value, but that will be the middle of my screen here. And if I just, after that, I'm writing multiply by bx, and the next thing I'm going to do is add ax with cx. So what does that do? Adding ax with our cx, which is basically our x coordinate. And remember, the cx is our x coordinate, and the bx, which is our y coordinate. So remember how we were saying about generalizing things? That means that if some person wants to make a change, some label wants to make a change in the, let's say, the x coordinate, then he needs to increase the value of cx, right? And then call the function, or then the animation will be like, okay, at one point our pixel was here, and at the next point it was here. So that's how this works. And if he didn't call that function, if that function was never called, that means that well, this line wouldn't really do anything. It will just add 0 to it, right? Now the next thing I'm going to do is move DIAX. This moves our final calculated value where the pixel has to be drawn into the destination index. This is needed because we'll be basically be drawing pixel through this new thing that we're using in this video, where we're pointing the extra segment towards our VGA memory. The next thing I'm going to do is move AX PP. Now, what does this do? Remember when we were moving PP to AX, we wanted to save the value of our color. So if our value of our color is 10, then it is saved in BP. So we can just restore it by, putting it back, putting BP back to AX. The next thing I'm going to do is a new thing, basically, is a memory offset, right? So what ES, DI, and AL. Now, ES and DI, let's understand what it does first. It writes our color byte, which is the AL, directly to the video memory offset. This is the video memory offset that we calculated. Remember, from ES, our VGA memory is starting, and it is going to where we want to go in the VGA memory. We want to go to the place which we just calculated by in these lines, right? So that's how, and then AL is our color, and that's how it's just basically going to print that, or like put our pixel on the screen. The next thing I'll do is pop A and then return. Pop A basically puts all the general purpose registers back to their original values which it was, because remember we were pushing the values, push A, which pushes all the general purpose register values up to the stack. And then we're popping so that we get all those values back. Return is just like a return statement. It returns the control back to from where it was called. So if it was called from a label, then it just goes back here. So for pixel, it will come back and start execution from here. The next label I'm going to write is the delay label. This will have a slight delay instead of like this, our computer like instantly printing the entire thing or putting all the entire pixels on the screen. It will add some kind of delay so that it gives that smooth animation effect to our animation. Yeah. Now, the first thing in this function I'm going to do, and this will be called, so I'll just push A so that all my general purpose registers are saved. Then I'm going to do move AH86H. This loads the BIOS function code for wait. It moves the BIOS call for wait function into AH, and then I'm going to just do int15H, which is the trigger for the BIOS interrupt. The next thing I'm going to do is pop A and then return. And how does this work? So it uses the CX-DX memory offset. What would be an example of it? So let's say our memory CX has 0x0000, and DX has, let's say 0x2710, I think. So this is like 10 milliseconds. You can calculate it. This is hexadecimal values. So I think this is 10 milliseconds. But that's how we'll be calling it. We'll be using these values and then call the delay function to add that slight delay. The next function or subroutine or label I'm going to write is the draw horizontal line. This will draw the horizontal line onto our screen wherever we want to put it. I mean, not wherever, because we won't be inputting values, but at least wherever in the code we can change the value. So by changing the value, we can change where we want to put it in the main.asm file, right? So the first thing I'm going to do here is push A. Remember, again, this is just a subroutine. This is a function. So we'll be saving all our AX register values. Now, the next thing I'm going to do is create a horizontal loop inside it. This is used because we want to start a loop of animation which goes again and again and again and draws that many pixels onto the screen. The next thing I'm going to do is call the putPixel function. This calls the putPixel function that we created before and draws a single pixel on the X and Y coordinates that were stated at the first. So it will be in the middle of the screen in the start. Then I'm going to do push CX. Why push CX? Because it saves our X coordinate because we'll be calling the delay function now. and then the dx. Now I'll move cx with 0x0000 4 zeros, and my dx with 0x2710. Yeah, that this complete value will be 0000 and 2710, which is equal to around 10 milliseconds. If you want, you can try calculating it, but I checked it, so it is 10 milliseconds. Then I'll call the delay function, and after that, I'll just pop dx first. Remember to pop dx first, otherwise it will create a problem, because remember we are pushing dx after. That means since stack is last in first out, I think. So basically, it's a stack of plates, right? So push dx is on top, and I have to pop it first instead of cx, because that will basically interchange the values. Then I'll pop cx. So this is good. Now, since this is a horizontal line, so that means I need to make changes in my x coordinate. So I'll do increment cx, which will increment my x coordinate value by 1 pixel, so 1 pixel to the right. Then I'll decrement bx, decreasing our length counter by 1. Then I will say jump if not 0 to edge underscore loop. So this will cause the loop to begin again and again and again until the bx value, which will become 0. In the end, I'll just pop a and then return. So this is our entire function for horizontal line, and we can even call it to create that animation. Now, the next thing is to do the vertical line. The vertical line is basically the opposite. So only thing that will change in this entire label or entire subroutine is that we are changing the vertical axis instead of the horizontal axis, right? Uh, and this is something that I want you to do yourself. It uses all the same things. So basically, this becomes V, so that you have the right naming conventions everywhere, and then you can use V over here, pushing A, calling, just change the horizontal, instead of horizontal, change the vertical coordinates. If you run into any kind of problem, you can access the GitHub repository where I have this code, as well as a very advanced library where I'm using the person hums algorithm for circle drawing, which is a bit complex, maybe for some other video, but you can have a look at it and check it out, how we can even animate a circle in uh, assembly. The next subroutine that I'm going to write is the draw square function. The draw square function will draw a filled square for the hollow square I'm giving you as a task. It's very easy. You have to change a few parameters. If you understand the filled square, then you can understand the hollow square as well and possibly draw it. The first thing I'm going to do in this subroutine is push A. Now this pushes all the general purpose resistors as we did earlier. Then I'm going to use BP as a thing to save the size of my square. So what I'm doing is in BX, our counter will be stored, which will count the height of our square. But I'm storing it right now in the base point register, so that when this value changes and I move to the next line, next row, then I can start again from what the original value was. So the square's width remains the same. The next thing I'm going to do is to write an inner loop, call it square while loop. And the other inner loop I'm going to write is the square x loop. In the square while loop, I'm just going to push cx and push dx because these values I'll be changing. Cx saves the x coordinate, position of the x coordinate, and dx is saving our width. Inside the square x loop, I'm going to call the putPixel function. So this draws our first pixel to wherever the position is that we have specified. I'll increment the cx, which is the x coordinate. So now our control moves one position to the right or one pixel to the right. Then I'll decrement bx and jump if not 0 again to square x loop. So this function or this label will keep on going unless we have reached the end of the row. The next thing I'm going to do is push cx. This saves our x coordinate, and then push dx, which saves our y coordinate, because I'm gonna be causing a little bit of delay here, and I'm gonna need those two register for the register offset. So I'm gonna do move cx 0x0000, and previously I did a 10 milliseconds of delay. This time I'm gonna do 20 milliseconds by 0x4e20. This causes 20 milliseconds. This is 20 milliseconds in hexadecimal. Now I'll just call the delay function, and this will cause our 20 millisecond delay. Then I'm gonna pop dx and pop cx. Again, popping dx first because of how stack works. Now I'm gonna move. Now I'm gonna increment dx, so our y-pole coordinate moves one pixel to the bottom. And then I'll decrement bp, which is my counter, and then I'll just jump, if not 0 to square y loop. So it goes back to this loop where the entire thing starts again until this counter has finished and we are done with our square. Then I'll just pop A and then return the call to wherever it came from. So in our case, it will be coming from main.asm. The next subroutine I'm going to write is the draw text animation. This will basically print and text to us, which we have mentioned in a certain register in kind of an animated cursor animation where first word appears and then the second one, and there's a slight delay between their appearances. Uh, so we're just going to do push A because everything in this library is indeed just a subroutine, because we won't be using this library or compiling it. We'll be calling it from other files, so main.asm in our case. Then I'll just do move A at 0 to edge. This loads the BIOS function code to the set cursor position. And then move B at 0, 0 edge, which loads page number to be 0. We don't really need to do that, but it's a good practice. Then I'll do int 10 edge, which triggers our 0 to edge, so our set cursor position. The next function that I'm going to write is an inner loop. So let's call it print loop. And then we're going to use something new called the load sp function. So what it does is that it loads the string uh, which is pointed by the SI register. So SI register is pointing towards our string in our memory, and it takes the first byte. So let's say if our string is main and it takes the first byte, which is the M, and loads it into AL register. So now my AL has the first byte. So what I can do for a finishing check is to compare my AL to 0. So if my AL is 0, that means that my string has ended and I don't really need to print anything anymore. Then I'll just say jump if it is equal. If the condition is true, then just jump to done, and we can create a done over here. Then I'm gonna write move A at 0 EH, which loads the BIOS function for the teletype output, which we're gonna be needing. So a teletype output, what do I mean by that? So if our string is main, it will basically print it like first M, then A, then I, then N. So kind of like a teletype input, if we know what I mean. Then I'll just call the interrupt, which is int10h, which will trigger the BIOS interrupt. I'll cause a bit of delay here. So move cx 0x0001, and then move dx, which is 0x86a0, causes a small delay. Just call the delay function and then jump back to print loop. So now this loop will continue unless this AL becomes 0 and our string has ended. Now I'll just pop in the done function and then just return. So this returns the loop. So now we're done with our library.asm. The next thing we'll be writing is main.asm, where we'll just be calling all the subroutines that we have written already, and we'll be setting the registers as well that are necessary for the position. So whatever position we want our animation to be, start from, we're just gonna move our work accordingly and move numbers or values. So if we are on the horizontal line animation on the vertical line animation, then we know that we have 320x 200 pixels, and we can move accordingly. So now that I'm inside my main.asm file, I have the org100h, and then I have hashing percentage include library.asm. This includes the entire, basically just copies the entire library.asm over here. So we're basically just including it so that we can call those subroutines. The first thing I'm going to write here is the start function. So that's where our control goes when everything starts. And I'm going to set the VGA mode in start by saying AX is 0013H. And we used to do move AH 00H and move AL 13H, but you can do it in one line by just saying 0013H. Then I'm just gonna int 10H, which will trigger the interrupt and will move to the VGA mode. So now instead of the text mode, we're inside the VGA mode. The next thing I'm gonna do is move CX to 50, which starts the X position at 50, and move DX to 30, let's say, which starts the Y position. And then I'm gonna move BX to 150, which is the length of my horizontal line. And then I'll just move AL to 9. This is the color. I think it's the green color, maybe the white color, I don't really remember, but you can name it anything. So I'll just call it 69 for now. And then I'll just call my draw horizontal line. And this will draw a horizontal line for me. The next subroutine that we're going to call is for the vertical line. So let's set its registers first. So the CX register will be 250 instead of 50, which was in the horizontal line. So I want something that's away from the horizontal line for this vertical line. Then I'll just call DX to 40 instead of 30, and then I'll my BX, which is my length, to 100. So a length of 100 pixels for our vertical line. And then I'll just call the draw vertical line. So this will draw our vertical line. The next function that I'm going to call is for the square. So again, I'll do move CX to, let's say, 100, which is our starting X position, and then move DX to, say, 70 for this, which is the starting Y position, and then move BX to 40, which is a size of basically 40x40. And then move AL12, which is just another color, and call the draw square function. So this will just draw our square, and you can control these values and try to draw anywhere you want. The last subroutine that I'm going to call is the text animation. So for that, I remember telling that for DH, we use DH for the row and DL for the column. And we have like 25, 18 to 25. So I think our rows are 25 and columns are 85. So if I just move DH to 20 and move DL to 15, I'll have in the left side somewhere, and then I'll just move my SI to point towards my string, which I will be naming later. So let's just call it my string. So now my SI, which will be used in our library.asm by load SP, is pointing towards our string. And then I can just call the draw text animation function. So this will just make that text animation for us. And then I'm just going to do move AX00H so that after all the animations are done, the program just doesn't end, but instead we have a key press. So we wait for a key press, and then I'll just use the interrupt. So this is the BIOS function for the key press. And later on, when we're writing a character controller, we will be using this to detect the keyboard input. So if we're pressing the left arrow key, then our character should move to the left. Now I'll just go back to text mode by saying 0030003h and then int 10h. In the end, I'll just exit my program for C00H, which exits DOS safely, and then int 21h. And then by the very end, I'll just do my string db define byte to ASM flow, which now becomes 0. So this is just defining my ASM flow, which is my string that will be printing. and I'm saying define byte, so it's a byte with 16 bits, and then I'm just saying 0. So what happens is that after printing it, the SI would start pointing towards garbage values until we reach 0. So we don't want to do that because memory is very important to us. So we're just going to point it towards 0 after this SI has done outputting. So it will move to the 0, and that will cause it to end that execution. So now we have written our library.asm and then our main.asm from where we're calling our library subroutines or functions. We can now move to outputting it. So let's open our DOS. So I fixed a few bugs here where we were popping DX instead of BX, and over here in the vertical line where I didn't call the put pixel function. So these are the two bugs that I fixed, and because of that our program wasn't working. So now that I'm inside my DOSBox, and as we discussed, we had auto exec turned on. So now these compilation lines are automatically executing as I turn on my DOSBox. So here I can just write my main, and our animation will begin. And then you can just change any kind of values. If you want to print it way to the right, you can change the registers accordingly. And if you want to make this square bigger, you can change the value of its counter accordingly. In the next video, we'll learn about how to add a controller to our character. For the next video, we'll be using our square that we're drawing as a character, and then using the arrow keys or maybe WASD to move the square right or left or up and down. And in the next video to that, we'll learn how to add gravity in assembly, and to give that bounce effect. So whenever our character jumps, we have that bounce effect. Next to that, we'll learn about bitmaps and how to create custom characters. So if you're interested in that, stay tuned.